All right, I saved the best for last when it comes to Riemann sums and trapezoidal approximations. The last way that we can find these approximations is when it's presented in a table format. So we've done the visual ones, which Delta Math does make the visual ones much easier than if you had to do them by hand. We've done the equation ones, which a calculator will help with, but they're still super tedious. Now we get to a table. So here's what's going to happen with these. They have to tell you what type of sum you're doing. So right, left, midpoint, or trapezoidal. They have to tell you how many subintervals we're slicing it into. But one thing you'll notice after we do a couple is they don't have to be even subintervals. All of the ones we did graphically and all of the ones we did with an equation, the way we were slicing it or partitioning it was always even. So now we're going to slice it in different ways where some of my rectangles or some of my trapezoids are going to be wider than others. That's still going to make this one, they're still going to be very easy. So here's what's happening. I'm going from 2 to 12. I'm splitting this up into 3 subintervals. We're going to use the right side, but I'm going to completely do this by looking at the table. So I'm going to mark this up a little bit just to explain it. So my first rectangle is going to go from 2 to 6. So that's 4 units wide. But since I'm using my right Riemann, I want to use the right side value with that rectangle. So my first rectangle is 4 wide, 12 high. My next rectangle, you'll notice it's not the same width. It goes from 6 to 9. That's 3 wide, but I'm using the right side of it to get the height. So it's going to be 3 wide by 4 high. And then my last rectangle is still 3 wide, so like the same width as the last one, but I'm using the right side to get the height, so 3 times 1. All you're typing into your answer is the numeric value you get when you do this. So 4 times 12 is 48. 3 times 4 is 12. So 48 and 12 is 60. And then plus 3, so you get 63. These, a calculator just makes it quicker. It's not actually necessary. A lot of times they'll work with easy numbers, so they can put it on a non-calculator. So that's a right Riemann. They show you basically the same work I did. So let me show you a left. I want to show you one of each. So my left Riemann, again, we are going from 0 to 7. We're splitting it up 4 ways. So my first one is going from 0 to 2, so it's 2 wide. But I'm going to use the left side to determine the height this time. So my first one is 2 by 25. My next one is also 2. And I'm going to use 22 as the height. So 2 and 22 are my dimensions. My next one is still 2. My height is going to be the left side, which is 17. And then my last one is only 1 wide, and I'm going to use 8. So 1 times 8. So I get 50 plus 44 plus 34 plus 8. All right, 44 and 34 is 78, and 50 is 128, and 8 is 136. If you miss these, often it's because you either added wrong or you just looked at a number and copied it wrong. So let's do a midpoint. So midpoint's kind of interesting because you have to have a lot more information because you have to know what's happening at the middle of each interval. So this one is going from 3 to 12. We're splitting it 3 intervals. So my first interval is going to go from 3 to 6. My next one's going to go from 3 to 9, and my last one's going to go from 9 to 12. The reason I have all this extra information is I need to use the middle of each interval, so that middle y value from the midpoint of the interval, as my height. Now you will notice with this one, we actually divide it evenly. We get this is 3, this is 3, this is 3. But we're going to do 3 times 8 for my first one, 3 times 16 for my middle rectangle, and 3 times 24 for my last one. All right, so what do I get? 24 plus 48. This is always the area that I'm convinced I'm going to mess up. So let's see, 72 and 48 is 120 plus 24, so 144. And it will show you. If I scroll down a little bit, maybe. Here we go. It will show you what we just did. So let me show you a trapezoid. Trapezoid's still pretty easy with the table, although it takes a little bit more work. But I still would prefer to do a table 1 over any equation 1. So this is splitting it into 4 subintervals. So we're going from 1 to 2, 2 to 3, 3 to 4, and 4 to 6. So they're almost even subintervals. So from here to here, from here to here, from here to here, and from here to here. So the height of my trapezoid is actually going to be how far apart these are. So 1, 1, 1, and 2. My bases are going to be these. So for my first trapezoid, my bases are 10 and 12 with a height of 1. Then my next one has a height of 1, and my bases are 11 and 12 because I'm using each base, the left and the right side. My next one is still 1 for the height, and I'm using 12 and 17. My last one does have a height of 2, and I'm using bases of 17 and 18. It's just in my way. 17 plus 18. Last thing we need to realize is we always have in our formula 1/2 the height times base 1 plus base 2. So after I do all of this, I need to cut my entire answer in half. I'm sure on Delta Math they'll put it all in with a half. I like to do the half at the very end. Just don't forget to do it. So let me figure out what we got here. This one's going to be 21 times 1, which is just 21. This one's going to be 23. This one's going to be 29. This last one is going to be 35 times 2, which is 70. So let's see, these are easy to add up. I get 50 plus 70 is 120, 143. Cut that whole thing in half. So what are we looking at? 71.5. So 71.5. That's how the trapezoid works. It takes a little longer because you have to use both bases, and then you have to figure out the height or the distance between the x values. So that is how you execute a table type of problem for all three Riemann sums on trapezoidal. And I do find that to be my favorite presentation of all of it because I think it is the fastest to work through.